Hello everyone, welcome to Techno Edu AKM. My name is AK Mishra, an experienced manager of facility organization. I'm here to talk to you about Fire Science Part A, which is represented in easy to follow step by step procedure to make the subject more realistic, understandable, and approachable. So, hello friends, let us come to the point. So, remember first, do not take any unnecessary risks and endanger your life. Security of life should be everyone's priority while dealing with the situations like fire. So, you should know what is fire, what elements are needed to start fire, how to control over, etc. This very session has a prime focus only on the fire science. Please keep watching yourself. Complete your knowledge with many related upcoming videos which are in my pipeline as fire safety inspection, evacuation plan, other features of fire protections and many more. So please subscribe and press the bell icon so that the all latest upcoming fire related videos could be offered to your court. Fire science, which is the study of all aspects of fire, from fire behavior to fire investigation. Before going in depth of the fire science, I'm trying to explain about elements which are needed to start a fire. I have a simple model as fire triangle or combustion triangle for understanding the necessary ingredient for most fires. Fuel, oxygen, heat are frequently referred to as a fire triangle. Add in the fourth element, the chemical reaction, and you actually have a fire tetrahedron. The important things to remember is take any of these four things away and you will not have a fire or the fire will be extinguished. The triangle illustrates the three elements. A fire needs to ignite fuel, oxygen as oxidizing agent, and heat. As you can see how heat is utilized to take a chemical reaction. A fire naturally occurs when the elements are present and combined in the right mixture. Now, friends, it is clear to all you about the fire, which is a chemical chain reaction that occurs when a combustible material is exposed to oxygen, during which oxidation results in the release of heat, light, flame, or smoke, along with various reactant products also. For example, carbon particles, sulfur dioxides, water vapor, carbon monoxides, hydrogen cyanides, and carbon dioxides, etc. In fact, in complete combustion at the time of fire, the reactant burns in oxygen and produces a limited number of product. For example, when a hydrogen burns in oxygen, the reactions will primarily yield carbon dioxides. And water similarly, sulfur will yield sulfur dioxides as well as iron will yield iron oxides, etc. Although nitrogen is not considered to be a part of combustion substance when oxygen is oxidant, still smaller amount of various nitrogen oxides, commonly designated as NOx species, from when the air is the oxidative. In most industrial applications and in fire, air is the source of oxygen. In the air, each mole of oxygen is mixed with approximately 3.71 mole of nitrogen. Nitrogen does not take part in combustion, but a high temperature, some nitrogen will be converted to nitrogen monoxides with much small amount of nitrogen dioxides. On the other hand, when there is insufficient oxygen to combust fuel completely, some fuel carbon is converted to carbon monoxides, and some of the hydrogens remain unreactive. Thus, the amount of air required for complete combustion to take place is known as pure air. On the other hand, there is a term named as incomplete combustion, which will occur when there is not enough oxygen to allow the fuel completely to produce carbon dioxide and water. Now, my friend, it is very clear to you about substances or materials which undergo combustion are called fuel. Fuel is categorized as liquid fuel, gaseous fuel, solid fuel. First, liquid fuel, where combustion of liquid fuel in an oxidizing atmosphere actually happens in the gas phase. It is the vapor that burns, not the liquid. Therefore, a liquid normally catches the fire only above a certain temperature. It is flash point. The flash point of liquid fuel is the lowest temperature at which it can form an ignitable mix with air. In fact, it is the minimum temperature at which there is enough evaporated fuel in the air to start combustion. Second one fuel is gaseous fuel, for example LPG, CNG. Solid fuel are wood, paper, plastic, cotton, etc. That's all. Now we will start classifications of fire. Most of us probably don't think much about the distinctions between different type of fires, but knowing the difference could be life-saving. Fire can be classified in 5 different ways depending on the agent that fuels them. Those are Class A, Class B, Class C, Class D, and Class K. Each type of fire involves different flammable materials and requires a special approach. In fact, trying to fight a blaze with the wrong method might make the situations worse. Class A fire are the easiest to put out. They involve solid material like wood, paper, plastic, or clothing. Class A fire are the most common type of fire and the kind that most of us are familiar with. They involve solid combustible material such as wood, paper, cloth, trash, or plastics. You might start Class A fire intentionally when lighting a match or starting a bonfire. Similarly, an unintentional Class A fire could result from knocking over a candle, a stray spark from a fireplace, or a lightning strike on a tree. Luckily, Class A fires are the easiest type to extinguish. As per the Fire Equipment Manufacturers Association recommended saying a water or foam fire extinguishers on Class A fire. You can also use water to douse the fire as it can remove the fire's heat supply. Class B fire involves flammable liquids like oil, alcohol, or gasoline. Here is, in such case, water should not be used to exterminate these fires. Class B fire involves ignitable liquids or gases like petroleum grease, black lubricating oil, alcohol, paint, propane, or gasoline. It is very important not to use a water extinguisher on a Class B fire, since the stream of water might spread the flaming material rather than extinguish it. Class B fire should be extinguished using foam powder or carbon dioxide extinguishers. This type of extinguishers work by cutting off a fire's oxygen supply. Then Class C fires involves a source of electricity. This type of fire might be started by old wiring in walls, frayed electrical cord, worn out breaker box, or faulty appliances. If possible, you should try to extinguish the flame using a carbon dioxide or dry powder fire extinguishers. But be careful about it, and when the power source is disconnected, the fire can become a different class of fire, typically Class A. So don't try to put out an electric fire with water or foam extinguisher, as both of those materials can conduct electricity and potentially make the situation more dangerous. Class D fires are rare but can happen when a metal ignites. We find these fires occurrence in industrial setting. It takes high levels of heat to ignite most metal. Class D fires are oftentimes caused by alkali metals such as potassium, magnesium, aluminium, and sodium, as this can ignite when exposed to air or water. In general, dry powder extinguishers work on metal fire by separating fuel from oxygen or removing the heat element of the blaze. But foam water extinguisher can potentially increase intensity of the flame and cause dangerous explosion. Some fire might also be termed Class K fire. Or Class F if they involve cooking oil such as vegetable oil or animal oil. This typically occur while cooking inside pantry because of high flash point of the cooking oil and fats. Class K fire often start when a pan is left unattended for too long on a stove. If possible, you will want to turn off the heat on your cooking appliance and remove fire from the heat source as soon as possible. Just as you should know to use water to try and extinguish a Class B fire dosing, a cooking oil fire with liquid is likely to create dangerous splatter effect and spread the flame. So my dear friend, you should extinguish a Class K fire only with chemical extinguisher. You know, these are mandatory in many commercial kitchen and are very good investment even if you do any amount of cooking at home.